So the goal for this video is going to be to walk through the NMR directions packet and show you how to work up a proton NMR spectrum well, but also to show you what I expected you to see as you did it and to encounter some of the problems and so on. So here it says you should see 3 tallish red lines with the tallest around 2 ppm, 3 tallish red lines, tallest right there at 2, some other stuff too, of course. But then it encourages you to come over here and click on the FT1 and just look at the original FID spectrum. And the idea here is that this is what the actual signal coming from the NMR is. And after you've done some math, you end up with a spectrum that looks like this. But big picture, the point is that that's all stuff that's happening in the background. Now what we need to do is learn how to play with the NMR spectrum itself, the proton spectrum, and to work it up well. Here what we have are some general commands. If you want to zoom in somewhere, you type Z, and there's kind of a toggle thing. If you want to zoom out all the way, then F and H are what I always use. The first thing that we need to perform to work up a spectrum well is to establish a reference peak. So here I have the normal cursor. If I want to zoom in on the region around 7, what I need to do is click Z, and then I can click and drag like so, and that allows me to zoom in. And then the directions say to hit L, which is the reference line tool, and when that is lit, if you click on it, then you can set this to 7.26, which it already is. You hit OK, and then in this spectrum you just hit F and H, and we are now back to where we started. And if I want to see what's going on down here at 0, I click Z to get the zoom tool up, and then click L for the reference line tool, and now I notice that this is off from 0.00. So I go 0.00 and hit enter, and then this will slide around. But now if we go back to the original CDCL3 peak, what you notice is that this right here is off. And so you have the choice of either having the CDCL3 peak be in the correct place or the TMS peak in the correct place. And if I have to choose, then I choose for this peak to be correct, the CDCL3 peak. F and H always returns me back to the beginning. Now we need to learn how to perform integrations in the spectrum, and the key idea here is that you want to be zoomed in on the region of interest, and whatever you integrate first will be 1 for the computer. And what you want to do is you want to click and drag from where it starts deviating from the baseline to where it ends coming back. So I integrated that first, so that will be 1. I integrate this, it will also be 1 approximately. I integrate this weird lumpy thing, and that's about a half, and half a proton doesn't make sense. And then I integrate that singlet, and that is 1.5, and that too does not make sense. The point being that even in the absence of knowing what the structure is, we should know that half a proton does not make sense. Therefore, we should probably multiply everything by 2 in order for it to make sense. Or, if I'm looking at the spectrum, this should probably integrate for 1, or this right here is probably a methyl group and should integrate for 3. At the moment in my spectrum, I have turned off the integral curve, but for the integrals, and so what I did was right click and go to properties. If I click on curve and then apply, you can see that in your spectrum, you probably have these integral curves listed up there. And so if I want to adjust the integral, what I need to do is click down here. If I right click while the integral is active and I go to edit integral, then I can change the normalized value of the integral to be 3. And now this integral is the reference integral. This is now a methyl group. This now integrates for 1H, which makes sense. And then I have 2 triplets, which also integrate for approximately 2H each, which again makes sense in light of the structure that we know we have, where we have a methyl, an OH, and then 2 things that should be triplets that also have 2 H's in them. One of the more challenging things for students when they encounter this the first time is this idea of doing the peak picking. And what I'm talking about in that area is that you get to decide what counts as a real peak. Now I'm going to turn off the integral curve again, so that's right click, come down to properties, and under integrals I can make it go away, but that's just so that I can clear up some space above so that it's not in the way. So K brings up the peak picking tool, and when I have the peak picking tool active, if I go this high up, then I have said that none of these peaks count, whereas if I go this high up, then there's at least 1 peak that will count. And in fact, it's telling me that 2 peaks count. This is a real peak that I like. This one, not so much. It's a bit of a shoulder, and I don't believe that that is actually a real peak. If I now were to highlight these 2, then I should have at least this little peak count as well. And if I highlight all of them, then again, I have a whole bunch of peaks that count. This would be what I'm trying to communicate. You get to choose what the threshold level is for the peaks. F, H returns me to all the way back out. If I use the zoom tool, Z, then I can once again zoom in here, and now I can peek pick across all three of these, and lo and behold, it is choosing a whole bunch of things as real peaks, including some that I wouldn't necessarily want. I imagine this to be here, here-ish, and here for the actual main peak elements. One of the points that I'm making throughout the document is that you cannot necessarily trust the computer. To a human eyes, this clearly has three main peaks, but all of these little sub things don't necessarily count. So don't just blindly trust the computer. What does this look like? This is a triplet. It may look differently if you were to use a different tool, but it's a triplet. You should treat it as such. Now, once you have chosen the peaks, then you can just simply read the chemical shift off of the numbers up here at the top, and the middle of this peak is right about there, so I would describe this as being 2.69 for the main value, because that's roughly where that is, or alternatively, if you are looking at the Crosshair tool, in the numbers in the blue box, 2.69 is definitely the middle of this peak. Or perhaps 2.68, somewhere in there though. Now comes one of the trickier things to do, and that is to measure the coupling constants for the peaks in question, and there's a fair bit of judgment involved in that. So coming over here, hitting C brings up the Crosshair tool, and what you're now going to try to do is to measure between the middle of the peak and the middle of the next peak over, which is approximately 5.33 hertz, according to the number in the blue box, the delta F1 number. But you may also get a pop-up box that shows up, and right about there is the same number, 5.33 hertz there. And likewise, if this is a real value, then I should be able to measure it to both directions and end up with roughly the same value. So 5.2 to 5.3 in this direction, again 5.2 to 5.3, 5.4 in this direction. If you are measuring this well, it should be consistent across the peaks, because peaks have symmetry, and it should be within about a tenth or so in either direction. More importantly, if you measure a J-value within a given peak, then it should be possible to also measure that J-value in some other peak as well. Otherwise, it's not a real J-value. So now we will zoom back out, and we will go and look at the other triplet and zoom in tightly on it. And then I will bring up the Crosshair tool again, and I will attempt to measure from the middle of this peak, say, to the middle of this peak, roughly. And that appears to be about 5.4, maybe 5.3, depending on where I measure it to. And again, this is 5.3, 5.4. So again, the whole point is that within this peak, you have approximately 5.3 or 5.4, but that also is consistent with the other triplet as well, which is as it should be. The process for working up a proton NMR spectrum from the beginning then is first to use the reference line tool to set the peak at 7.26 if you have it at precisely 7.26, because that is CDCL3 and that is your reference point. Once you have performed the reference, the next thing you want to do is perform a good integration, which are going to be the numbers down here at the bottom. And again, what you use is the integral tool, and you click and drag across each peak in turn, and there's some judgment calls along the way. Where exactly do you think this lump starts and ends, for example? But also, if you have some nonsense 0.5 values or some other values that you need to interpret, then you want to right click and go to edit integral and set a reference integral for whatever peak you think you have identified. Often, picking a small one and setting it to be 1 makes sense. Also, if you can identify a methyl group, that is an excellent reference. But in general, what you want to do is make sure that you have a number of total hydrogens in the spectrum that are consistent with the structure you suspect you have, or consistent with your molecular formula, or sometimes, if you don't have any of that information, you're just guessing and you're trying to come up with numbers that actually make sense. Once you have successfully done the integration, then the next task is to identify where the peaks are, and you can do that with the Crosshair tool. So this peak, if I call the high point right about there, then it's at 2.52, and this singlet has a high point that's right about there, so that's 2.18 or 2.17 or thereabouts. Or you can just simply use the Crosshair tool, and again, if I simply cut across this peak with the Crosshair tool, then 2.18 or so is where the high point for the singlet is. And you have all these blue numbers up at the top that are the chemical shifts, but you can just use the Crosshair tool to measure where these are, and the middle of any peak, or the highest point if you have a lump, that's where the peaks are. And then finally you need to extract the J values, and for that what you do is you zoom in on a given peak and use the Crosshair tool to measure from the middle of any one line to the middle of adjacent lines. And if the peak is in fact a nice well-behaved peak, then what you will notice is on both sides you should get roughly the same value.